Have you ever noticed that around the office it seems like there's certain types of information that just spread like wildfire? I mean, sometimes the person who's about to get a raise or a promotion is the last one to know because the rumor mill around the office has already informed everyone else about what's going on. And when it comes to NSX routers, we'd like for them to gossip. We would like to be able to have the ability for those routers to share what they know with other routers. Not in a free-for-all, but in a controlled way according to a protocol. And in this nugget, we're going to look at how to enable OSPF, a dynamic routing protocol, on NSX, DLR, and Edge routers so that the routes that they are connected to can be shared with other routers. So to get all up and interactive, we're in the VMware hands-on lab, specifically in HOL 1903. We've logged on. We fired up Google Chrome, our browser, and logged on as administrator at vsphere.local with the handy password of VMware1! And from home, we've headed over to networking and security, and we're currently viewing the dashboard. So where are we going from here? Well, our goal is to work with routers right now. So where is that going to be on the left-hand side? That's right, NSX Edges. Edges means routers and beyond. And we currently have two routers, an NSX Edge and a local router. And for this exercise, we're just going to quickly reconfigure them so we can then add the element of dynamic routing. So we'll open up the Edge device here, then we'll remove the app tier and the DB tier configuration. Once those two are removed, we'll click the back button to get back to our list of NSX Edges. Then we're going to open up the logical router. Likewise, head to the Manage, Settings, Interfaces tab. Then we're going to click the green plus to add interfaces that are connected to the app tier and DB tier respectively. So for the first interface, we'll name it app_tier, leave it internal, click select to connect it to the app tier logical switch. Click the green plus to add a subnet IP address of 172.16.20.1 with a subnet prefix length of 24, then click OK. Then we'll click the green plus again and add a DB_tier. Click select, add it to the DB tier logical switch. Click OK, click the green plus, add the primary IP address of 172.16.30.1, and click in the subnet prefix length and add 24, then click OK. So now that we've done that, what we're seeing right here is really the essence of our routing table, because all we have are the interfaces that we currently are connected to. But let me show you how we can verify that. Let's open up PuTTY from the taskbar, and we're actually going to connect to the distributed logical router. Now wait a minute, how do we connect to a DLR when the DLR is on all of our ESXi hosts that are in the transport zone? The answer is we connect to any of those ESXi hosts that are in the transport zone. So let's select ESXi 01. That's one of the places where we'll find the DLR. There's a series of commands that we can run that begin with net-vdr that can reveal a lot of this information to us. In this case, if we do -l space -i, we actually get the VDR instance information. So we can learn about this virtual distributed router and identify information about its controller IP, the control plane IP, and basic things like what's its name and how many routes does it have. To see those routes in more detail, we can type in net-vdr -l space --route space edge-3, the name of our VDR in this case. We'll press enter, and it's a little ugly. Let's maximize the window, up arrow, and do that again. And there's a nice tight little routing table, and we can see that all we have right now are these routes based upon the interfaces that we're directly connected to. Let's minimize PuTTY for now, and let's make this router a little smarter. To do that, we're going to head first to the routing tab here under Manage in the distributed router. Usually one of the first things we're going to want to configure is a default gateway entry. So let's click Edit under Default Gateway and set up our gateway of last resort, our default route. We'll choose the transit network from the list of interfaces and put in the IP address of 192.168.5.1, which is actually the Edge router, and then click OK. Now what we see next is something we've got to get really comfortable with, and that's this idea that we're making changes in the NSX manager that then need to be pushed down to all the instances of our distributed logical routers on each ESXi host. So instead of trickling all that configuration down constantly, what we can do is kind of bulk up those and publish those changes. And the flip side is, because we haven't pushed those down yet, we could also revert those changes. For now, let's just publish changes. And once those are published, let's bring back the PuTTY window, up arrow, and see what we get in our list of routes. The gateway of last resort entry, all zeros with the mask of all zeros, and the next hop router IP address of 5.1. Let's minimize that, and let's take a look at the static route configuration. We could add a static route to identify a remote network that we'd like to be able to support routing to, such as the 192.168.3.0 network /24, and identify the next hop IP address is 192.168 5.1. And then identify the interface that we use to connect to that, which in this case would be it's off of the transit network, and then click OK. So static routes allow us to configure all of those options in a very manual sense, identifying each and every network that we'd like to support. In this case, rather than static networking though, we'd like to be able to exchange networks. So we're going to go ahead and click the red X and remove that entry. We can publish changes, and then let's take a look at configuring a dynamic routing protocol that will be shared between the edge router and the DLR. To do so, we're going to head to OSPF, which is one of the two dynamic routing protocols that are supported. Under OSPF configuration, we're going to click Edit, and from the drop-down menu, say that we'd like to support it on the transit network. The only interfaces available here will be uplink interfaces. And then put a check mark in to enable OSPF. And this gets interesting because we have to add a protocol address. In this case, we'll put in 192.168.5.3. Now, to understand what this address is, we need to remember that every ESXi host that is supporting this DLR routing, that owns a copy of this router essentially, must have the ability to communicate with adjacent routers. In this case, with the edge router. But the communication cannot be router A contacting router B, C, and D, because B, C, and D are really just one router that is distributed across 3 ESXi hosts. So we need to make this seem as though it was just a single instance. And that is why, when we originally deployed this virtual machine, we had the ability to configure an edge VM to support a distributed logical router. And it said the reason for that was twofold. It's to support firewall configuration and what we're doing right now, dynamic routing. It's to enable a single point of contact for the sharing of distributed routes. So the IP address that we're entering is the IP address that will be used by that edge virtual machine that we configured for this router. And the forwarding address is what we're using to actually push packets out into that network, which is 5.2. So we'll click OK. Let's go back up to global configuration, because under global configuration, there's a section for dynamic routing configuration, and we'll need to enable that here. So we'll click Edit, and we have a place that has a default router ID that gets defined, which is perfect. We just need to select that and click OK to enable support for dynamic routing. Again, we can publish those changes. Once that router ID has been defined, let's go back to OSPF and let's publish our changes. Down at the bottom, we'll need to create an area to interface mapping, a way to connect certain areas to that. So we're going to indicate that our transit network is going to be a part of Area 51. And this is important because without associating an interface with an area, we have no way to start communicating about the networks that we participate in. We'll leave it with the area pre-configured here for this lab, Area 51, and click OK, and then publish our changes. For this lab environment, Area 51 has been created, and the way this is going to work is that Area 51 is going to be used by the router to share information with another router. This is the common area where they are willing to share all of their routes with full detailed information. We're going to leave it with the default Area 51, but we need to map that area to an interface. So down at the bottom, we'll click the Area to Interface Mapping. From the drop-down menu, we'll choose the Transit Network 01, select Area 51, leave it with the default configurations, and click OK. Then we'll publish our changes. Now this is great, but we need to have an equivalent configuration on our edge router. So let's go up to the Home button, down to Networking and Security, hop over to NSX Edges on the left, and then double-click our edge device and see how it's currently configured. Let's hop over to the Routing tab. Under Global Configuration, we need to make sure that we have a router ID. We do. And we can see that OSPF is stopped. So let's go ahead and go to OSPF. And under OSPF Configuration, let's go ahead and click the Edit button up at the top and put a check mark in to enable OSPF. Then we'll click OK. Let me publish my changes. And if you look carefully in the center section, once that's done, you can see that there's actually two areas here on the edge device that have already been predefined for this lab, Area 51 and Area 0. Let's click the Area to Interface Mapping down at the bottom. And the Enterprise Uplink is going to be associated with Area 0. So we simply choose the VNIC in the area and then click OK. Then we'll click the green plus again. And from the drop-down menu, the Transit Network is going to use Area 51. So we'll select that and click OK. Then we'll click the green plus again. And from the drop-down menu, we'll choose the Web tier. And we'll associate that also with Area 51. We'll click the green plus. From the drop-down menu, the Collapsed App tier, Area 51. Click the green plus, drop-down menu. the Windows tier, Area 51. So sharing full information with with the adjacent router, in this case, the DLR. Then we'll click Publish Changes. And if we want to see what that local routing table looks like on this device, up at the top, let's go over to VMs and Templates. And this virtual machine is actually called Perimeter Gateway 010. And because it is in fact a VM, we can simply select the thumbnail to open up the interface. Once we wake it up, we can log in as admin with the password of VMware1 exclamation point, VMware1 exclamation point. If you're familiar with the type of commands that are used on a typical router, you're going to find yourself at home. So for example, show IP route reveals the local routing table. And we can actually see right there that we've got a couple of OSPF routes, N2 because it comes from what's called a not so stubby area. There's the 20 and the 30. And we know that this edge device is not connected to those switches. We actually yanked its connections directly from those. Instead, it's gaining that information indirectly from that DLR. Let's actually hop over to our PuTTY window, up arrow, and let's take a look at our routing table using NetVDR. And this table got a lot more exciting as well. We can see the additional automatically supplied information that tells us that 5.1 is a gateway to get to all of these various different remote networks. Again, learned by the power of OSPF. And as a final test, let's go back to the vSphere web client, and let's actually go to app1.corp.local and click on that thumbnail, put in the VMware1 exclamation point password, and if we check our ifconfig, we're at 172.16.20.11. Let's ping and see if we can support access to our edge router, which is at 192.168.5.1. We have success. And let's even test visibility to our web device, which is actually at 172.16.10.11. And so we have full routability all the way out to the router and back from remote devices because the routing configuration has been supported with the dynamic routing protocol. It is very handy to have your routers do the heavy lifting of informing each other of the routes they know rather than you having to configure static routes for every configuration. I hope this has been informative for you, and I'd like to thank you for viewing.